Hello, everyone. My name is Franklin Lewis. I'm at the last semester of MS Data Science at U Bloomington. As part of the final project, I've chosen topic of my greatest interest, airline operations. The primary paper I chose is the airline flight delay predictions using the machine learning. It's by Yuming Tang, University of California. And based on the reference on the citation, and the citations from the first primary paper, I have chosen other two papers, that's machine learning techniques for analysis of Egyptian flight delay by Shahinaz Tabak, Hana Mohammed, and El Zahad. And the third paper chose a supervised learning approach to flight delay predictions by Mehmet Kemal Atloglu, Mustafa Bolat, Murad Sahin, and Volkan Deniz. A brief introduction. As people increasingly chose to travel by air, the number of flights that fails to take off on time also increases. This growth exacerbates the crowd situation at the airport and causes financial difficulties within the airline industry. Airline industry is known for bankruptcies. Major players in the US aviation, American, Delta, and United have gone through the bankruptcy in the past. We have seen a lot of major players like US Airways, Continental Airways went on to the merger. There's a huge list of global airlines became the victim of the financial crisis. One of the important reasons for the financial difficulties for the airlines is the customer dissatisfaction. This happens when the flight delays and cancels increases the crowd situation at the airport, paying more to the airport for the aircraft parking time. A study, Total Delay Impact, reports that the total cost of the air transportation delay to air travel and the airline industry in 2007 was 32.9 billion in the US, resulting in a 4 billion reduction in the GDP, eventually taking the toll on both the airline companies and the passengers. To help identify the issue and resolve the situation, machine learning models were implemented to predict flight delays. Let me right away jump into the taxonomy table for the paper, and I'll try my best to get into the nuances of the topic and findings in details. The first paper, airline flight delay prediction using the machine learning. There's 7 algorithms being used that has listed here, all the 7 algorithms. And the data source is from the JFK airport 1-year departure flights. This is a supervised learning algorithm type, and the tools used is a Scikit learning package for Python. In that algorithm, the first 5 of them are called the base classified because only one classifier instance is trained for each one. The rest 2 of the algorithms are called ensemble classifier because more than one instance of the base classifier are trained. And their collective decision is reported as the final predictions. As 2 of the most popular ensemble algorithm, random forest and the gradient boosted tree, combine several individual models to improve the performance by more accuracy and less variance. A tree is built and its prediction is evaluated based on its residual errors. Therefore, each tree model learns from mistakes made by the previous model. The building of new tree will stop when an additional tree cannot improve the prediction. The data is given along a single root node tree. Also, this paper applies 10-fold cross-validation to get more reliable model. On the paper 2, machine learning technique for analysis of Egyptian flight delay. The data source is Egypt Air Fleet Watch Management System. And it's a supervised learning, and the tools used is the Vika package, which was developed using Java. Various lists of techniques are available for the classification, like decision tree, induction, Bayesian classification, and Bayesian network. Decision tree is a model which is used on most classification in the work. It has tree-like structure in which all the internal nodes, including the root node, represents an attribute, and the left node represents the classification. The leaf node represents the classification categories as per the goal class. The basic concept by which classification is done in decision tree is to take the multiple linear decision to perform a non-linear classification. Decision is taken at every level of the tree. Finally, we arrive at leaf node, which leads the instance to belong to a particular category. Decision tree uses a top-down divide and conquer as classification structure, and it is partitions a set of given entities into further smaller classes on the basis of automatically selected rules. This paper uses weak class, as I mentioned. It has a classification tree and a ruler. There are multiple descriptions like tree, decision jump, J48, random forest, reap tree, and there are a few rules like part, decision table, 1R, and JRIP. On the third paper, supervised learning approach to the flight delay predictions. In that paper, they trained 11 different classification models for each experiment data set using 11 different classification algorithms. And I've given all the algorithms here. It's a supervised learning, and it's used in Python. The evaluation metrics, I will get into the detail on the next slides. I just will put together a taxonomy for algorithm. I can call it as a classification of algorithm as well, where the algorithm that is used, where it falls, is it fall at the classification, or regression, or clustering, or deep learning. Here's the evaluation metrics or formula. On the baseline, all three papers uses the confusion matrix. The paper one, the performance of the classifier can be calculated for the confusion matrix. After being compared to the actual test result, the classifier result can generate 4 values that I've given here. That is a true positive, true negative, false positive, and false negative. 4 measures were used to measure the performance of selected algorithms. That's our accuracy, precision, recall, and F1 score. These measures are all positively related to the quality of the algorithms. Consequently, for the specific algorithm, higher value of the measures are the better the performance is. The value of the 4 measures can be obtained by calculating using these parameters. Also, the imbalanced nature of the data set made it necessary to use weight precision, recall, and F1 score for each algorithm. First, the ratio of the correctly predicted sample is calculated for each label. Then these ratios were weighted by the proportion to the total number of sample and are summed to get the weighted average. On the second paper, the distinguished confusion matrix was obtained to calculate sensitive specific precision recall, F measure, ROC, and accuracy, which are the metrics of evaluation of these classifiers. Confusion matrix is a 2x2 matrix representation of the classification results. The number of correctly classified instances sum of diagonals in the matrix. All other are incorrectly classified. The formulas were used to calculate metrics of classifications, namely true positive rate, false positive precision, F score, ROC area, and accuracy. They used to use the confusion matrix to see performance of each classifier. The classifier used in this work is more efficient when it comes to 70% results. And the paper 3, in order to measure the classification of the selected algorithms, they used precision, recall, F score, and ROC area metrics. Since the data set was imbalanced in terms of class distribution, these were very reliable metrics to predict the model performance in a real-world scenario. For example, for this metrics, the higher the metrics value, the higher the performance of the classifier. And this is the formula that's been used. This paper used related metric functions for the skit-learn package with the average parameter to set to weighted in order to take into consideration the imbalanced nature of the class labels. With the option respective measures are calculated for each class independently, and then their average weighted by the number of true instance for each class is calculated. This is the comparison of all three papers. This is the results, just a given comparison. In that, it's very clear to see the paper on the airline flight delay prediction using machine learning has yielded the best results of 0.9778, and we have other two papers is not yielding the result as good as the first one. And I will get into the detail for each one. Looking at the first one, the first paper, the value of each evaluation measure of every algorithm is present in here. The highest value of the measure is shown in the table with the bold font, and the lowest measure is labeled with an underscore. Here you can see that. One of the best performance among the 7 algorithms is the decision tree model with the accuracy of 0.9778. Next to that is the gradient boosted tree, which has a second greatest value of 0.9334 accuracy. Beside the decision tree, the two based ensemble classifier, random forest, and the gradient boosted tree are also better performance than the other, and the value of measure of these two algorithms are relatively similar. For the low score, KNN has lowest accuracy and the recall, while Gaussian naive Bayes has the lowest precision and F1 score. Therefore, it's possible to conclude that the worst performing algorithms among the 7 selected models when predicting the given data is given data set is the KNN model. On the paper 2, the model performance in terms of classification accuracy for the 4 rule-based algorithms and 4 tree-based algorithms using various accuracy measures like TP rate, F1 score, and ROC area. Accuracy has been measured on the data set by many criteria of evaluation. But the most important criteria of accuracy is the F1 score and ROC area. It was found from the comparative analysis that classification method rules part performed best with the classification accuracy of 0.831. Destination table. Destination table came out the classifications of 0.814. But 1R came with a classification accuracy of 0.784, JRIP with a 0.794 among those all rule-based classifier. For the tree-based classifier, the method RIP tree had 0.80.3, but the method decision stump and the random forest came out with a classification accuracy of 0.782 and J48 with a 0.74.7. The paper 3, the decision tree and KNN algorithm shows consistently good performance. Among all cases achieved 0.816 and 0.807 F-score relatively. Similarly, GBX, XGB, and LGBM algorithm shows very good performance in most of these cases, achieving F-score around 0.810. GNB, RF, CB, SVM, LR, and MLP algorithms, on the other hand, did not show the acceptable performance. That's all I have. If you have any questions, if you need more information, please feel free to give the feedback, and I'm more than happy to collaborate everything into my final paper. Once again, thanks and appreciate the time. Have a good one. Thank you.